Here we are with 7.5 Binomial Probability Day 1. This is actually one lesson broken up into two different days. So our objective today is that students will be able to find binomial probability, and this is a new term for us today. So inherent in combinational probability is the idea that we can sample without replacement, but there's many probability problems that involve sampling with replacement, or better yet, where the successive event is not affected by one prior to it. So remember we talked about combination and permutation. One of them order matter, order does not matter. Combination, the order does not matter. Permutation, the order matters. So it's similar to this. In this case, it will be easier to work with problems using the fundamental probability law, which we're going to talk about in exercise 1. Consider tossing a coin, which is heads or tail, and rolling a die, which is 1, 2, 3, 4, 5, or 6. Write the sample space to this experiment using the list of order place. So let's go look at it this way. So we're starting with a head. Head can go to 1, head can go to 2, heads can go to 3, heads can go to 4, heads can go to 5, and then heads can go to 6. So that's like me saying this goes to 1, this goes to 2, this goes to 3, this goes to 4, 5, and 6. And we also know that the tails can do the same thing. Tail go to 1, tail go to 2, tail go to 3, tail go to 4, tail go to 5, and tail go to 6. And those are my possibilities. We could have done this in a tree diagram, but it says write it out. Then it says, determine the probability of getting a head and a number less than 3. So now we're going to go back to look. A head with a number less than 3, it can be either 1 or 2. So the probability is either 2 out of, how many choices do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 out of 12, which is the same thing as 1 over 6. What are the individual probabilities of getting a head and getting a number less than 3? So the probability of getting the head is 1 out of 2 choice, because I can get a head or a tail and then get my head. And the probability of getting a number less than 3. What's the probability of getting a number less than 3? On a die, a number that's less than 3 is 1 out of 2. So there are 2 choices out of 6. So again, this is from the coin, which is heads or tail, 2 option. This is from a dice, which has 6 options. How could your answer in C, which is what we just did, use to calculate the answer in B? So think about what we talked about earlier. So it has to be, I'm being asked to find a probability that it's a head and it is less than 3. And again, we says and means multiplication. So it's 1/2 times 2 over 6, which is actually 2 over 12, or 1/6, which is what we get in B. Okay? Now we're going to move into something called a fundamental probability principle. It's just when you have an event, let's call it E, and it's broken down in a sequence of n events, where it's broken down like event 1, event 2, event 3, blah blah blah. The probability that the event will occur is given by this simple equation below. Now this principle can be applied to what we know as the binomial probability problems. These occur anytime an event is comprised of repeated trials of the same experiment where the probability of a successful outcome does not change the trial after trial. The formula for this probability will be developed in this exercise. So now, what am I talking about? So let's take a look here at exercise 2. I'm going to get some space. On a 5-question multiple choice test, there are 4 choices per question. What is the probability of exactly 3 out of 5 questions? What's the probability of getting 3 out of 5 questions? So the probability of one question, correct or incorrect, can be what? So if you get the answer correct, so the probability of the answer being correct is 1 out of 4 choices, because there are 4 multiple choice, A, B, C, or D, and we know it's one answer. And the probability that it's not correct is going to be the 3 out of the 4 choices. So let's say I'm going to write it A, B, C, D. These are my choices. A is my correct answer. So the probability that it's correct is 1 out of 4, and then it's not correct is these B, C, and D remainder. Now this is done. We're going to go into now, think about, it says any sequence where 3 are correct and 2 are incorrect. So if 3 questions are correct, it's going to be a quarter times a quarter times a quarter times, and then there are 2 that are incorrect. So these are the 3 correct questions, and these are the 2 incorrect questions. This can also be written as the same thing. This is the same thing as saying a quarter to the third and 3/4 to the second. So this is our first step. This is how we're going down. Now we want to think about, since there are 5 questions and you're choosing 3 ways, 3 questions, any 3 questions, you're choosing 3 that are correct, your final probability is, so I'm going to write this out. So it says, since there are probability 5, choose 3, because it doesn't matter the order that we get the 3 questions correct, of choosing 3 questions that are correct, our final probability is, so this is how many ways I can answer 3 questions. It doesn't matter what 3 question I answer, but it just mattered that I get 3 correct. So the final probability will be written as C, 5 choose 3, and then there's a quarter to the third, that's my 3 question, and then the probability of getting those 2 wrong. This can be simplified. I'm going to do it piece by piece, which is 1 over 64 and 9 over 16. Put all of this in my calculator. I should get 90 over 1024 or 45 over 512. Either one's doesn't matter because I didn't say simplify. Now, I know it's a lot. That's why I was nice enough to tell you the binomial probability formula is going to be something that looks like this. So think about, if we have an experiment that runs with n trials, the probability of the success is given by P, and then the probability of the failure is Q, and this is what it's going to be. So you're going to have P is equal to the combination of something. P is your successor, meaning the positive, yes, it's happening, just like we saw the correct answer, and Q is the failure. But you have to be careful, because when I add P and Q, I need to get 1. In the previous example, it was a quarter plus 3 over 4 will give me 4 over 4, which was 1. And then my exponents here is R, and then here is n minus R, so whatever is given. Now, exercise 3. On an equatorial island, it rains very consistently. If the probability of it rain any given day in this week is 2 over 3, then find the following. The probability it will rain on exactly 5 out of 7 days. So the first thing you want to do is, what is my P and what's my Q? So think about it. This is the probability that it's going to rain. So my P is actually going to be 2 over 3, and then my Q would be 1 over 3. Again, when I add these, I get 1. So let's go ahead and do the probability. The probability is equal to the combination. It says 7 days in a week, and the probability that it will rain 5. Then I do the success is 2 out of 3 for 5 days, and 1 out of 3 for the remaining 2 days. This will actually be 21 times 32 over, that's a 2, 32 over 243, and then this is 1 over 9. All of this is equal to 672 over 2187. You can simplify or leave it as this is perfectly fine. Now B says, find the probability it will rain exactly 1 out of the 7 days. So now we're doing 1 out of the 7 days. So the probability would be 7 days, 1 time it's going to rain, and then it's 2 out of 3, 1, and then 1 out of 3, 6. Because it's going to rain 1 time, the success is 1, and then this would be n, which is my total, 7, minus 1 is 6. This works out to be 7 times 2 over 3 times 1729, which is equal to 14 over 2187. This cannot be simplified, so that's my final answer. So think about when you're working with binomial probability formula, you need to know what is your P and what is your Q. What is the success? What is the failure? Now let's take a look at some multiple choice question here. Exercise 4. Which of the following represents the probability of getting exactly 4 heads when flipping a fair coin 8 times? So the probability, I'm flipping the coin 8 times and I need 4 heads. What's the probability of getting a head? The probability of getting a head is 1 out of 2, and I'm looking for 4 of this, and then 1 out of 2 and looking for 4 of this. This will be 70 times 1 over 16 times 1 over 16, which will give me 70 over 256, which will go ahead and simplify to 35 over 128, which is choice 3. What is my success? What is my failure? That's it. Now they can be given in decimals as well. So whoever this girl is has a probability of making free throw in a basketball game of 80%. So that's her success. My success is 80%, which in terms of decimal is 0.8. So therefore my Q or my failure would be that 20%, which is 0.2. See how I made that up? If she shoots 6 free throw in a given game, which of the following is the closest probability that she will make exactly 4 out of 6? So probability, she wants to know, we want to know it's 6. She's shooting 6 times. We want to know 4 out of 6, and then her success is 0.8, 4, and then 0.2 goes to 2. All of this will work out to be 0.247, no, 245, sorry, 0.2457. And if I multiply this by 100, because my answer are in percentage, I will get it to be 24.57, which is approximately 25%. Again, choice 4. Our last exercise before you go and practice on your own. A good hitter in a professional baseball will get a hit about 1/3 of the time he comes up to bat. What is the probability that a good hitter will get a hit each time if he bats 4 times in a game? So it says each time, meaning he will hit 4 out of 4 times. So the probability is that 4 choose 4, because he's getting each time in 4 games. It's 1/3 times that he will get a hit, and it's going to be 4, and then 2 over 3 to the 0. Work this out, it becomes 1 to 1 over 81 times 1, which is 1 over 81, choice 3. And that's how you see it on the Regents question, guys. Let's see, you can do this. I know it's been difficult. Remember, pause the video, go back, look at it, explain, ask me question, ask Miss Ewing question. Any one of us will here to help you. Pause it and just come back and see us. Alrighty? Good luck!